Can everybody hear me okay?
Hi, I can. It's Eva.
Okay. Hi, Eva. Thank you. Okay, I have a new piece of technology I'm going to attempt to incorporate today. I'm just going to go get it. I'll be right back. Looks like we have about 2 minutes. Oops. Great. So, I think I have to stop sharing. So it's 5:30. So I think I'm going to go ahead and take attendance. And we can get started. Is everybody remote today? Cool. Great. Okay, so let's see. I see Kelly, Catherine, Eva, Dakir, Karen, Anna. Who are we missing? Caitlin, I see Caitlin. So it looks like we're missing Jackway. And Dana.
Tim is missing. Still.
Tim is, yeah, Tim.
Yep.
And was Elizabeth here? I don't see Elizabeth. Okay. Okay. Well, let's get started. Yesterday we were talking about regular expressions, and we were going to follow up on yesterday's assignment. Was anybody able to successfully complete it? Like to share the solution? Let's start a REPL.IT session, and we can work on that. Let me share my screen as well. Okay. And I'll start up the REPL IT session. Let's close all of this out. Can everyone see my screen? Oops, let's reload this. I'm gonna drop this in Slack. Students. I see people joining. That's very nice, very good. Oh. One moment. Okay. So let's take a look. Let's take a look at this thing again. All right. So we wanted to replace the single quotes with double quotes, but not when it's used in conjunctions like I'm and it's. And we started to make some progress on that. So we were able to replace one of the single quotes with double quotes, and we managed to not replace the single quote and the contraction with double quotes. So we were making some progress, and let's just continue reasoning about this, and we'll try to work it out. Oh, by the way, did anybody have any questions from yesterday before we dive into this? Just interrupt me if anything comes up. Okay, so we need to basically excuse me. So initially we were thinking that we wanted to isolate only the single quotes that were not preceded or followed by a letter character. And so it looks like we found one of those. So this says basically match everything that doesn't have a letter character before it and doesn't have a letter character after it. Or I guess that's alphanumeric. So I guess actually for that reason, I'm a little bit surprised that it matched this guy because it does have a letter character before it. Am I misunderstanding what's going on here? Oh, wait a minute. No, it's because it got rid of the comma. The comma is not a letter character. And we were adding the space back in, right? that was the other thing, is it was stripping out the characters that it was matching. So we had to address that too. So right. So I think I'm just going to like plow right through rather than making this part like super interactive, because we got to get to like today's lecture content as well. So I'm just going to like blast through, and then we can circle back around with questions maybe toward the break. So here's how I would imagine doing this. So okay, so first we have two problems, right? First problem is that it's not matching certain single quotes. So we have a matching problem. And then the second issue that we're encountering is that it's basically like deleting or like filtering out. Like basically it's replacing certain characters that it matches with null values. So it's delete. You don't get the characters that you want in the result. So we can break this down into two different problems, and we'll solve each problem individually. So for the first problem, so what isn't it matching? Well, it's not matching this first single quote. Can anybody see why it's not matching that first single quote?
We only told it to match if it had white space in front of it.
Well, not white space, but
like letter. Sorry, not white.
Yeah. Well, anything that's not a letter.
Right.
Exactly. So, how could we resolve that? Well, I think one way that we could resolve it is if we use the start of line character, and we could say, okay, either the start of the line or a non alphanumeric character is valid. Let's see if that works. Okay, that did not work. So I was wrong. Maybe the other way that we could do it is if we are at the start of the line, then the non-white space character is optional, perhaps. And then maybe if we're not at the start of the line, then it is not optional. This might be too complex. Let's see if it works. Okay, that also did not work. So maybe we only care about if we have a non-white space character or a non-letter character following it. Let's see about what happens if we just do following. Oops, invalid. Right, that's because we need that. Still not matching that first guy. Why is that? Oh, of course, it's because the character that follows that initial quote, single quote, is a letter. So of course it wouldn't match that one. So yeah, so we really need, like, basically it's like we want to like take the it's like we want to take the negation. Like we want to go yeah, let me think here for a second. Ooh. There's a way to do this. which would be really quick and kind of ugly, and it's probably not the right solution. Like there's a way to do this just with a regular expression. And then there's sort of a slightly evil, I mean, it's not evil. It's just probably not the most technically correct way to do this. But I don't know. I think we got to move on to today's slides. So I'm just going to do it. And then we're going to come back later and we'll figure out the right way to do it. Okay. So the way we're going to do it is we're going to match all quotes. I feel kind of bad about doing it this way, but we're going to do it. Okay. We're going to match all quotes, and we're going to put all of the logic into the replace function, so that when we get a match, then we're going to use the index of that match moments. Oh, that's why. Okay, now we're good. Okay, so we get all these quotes. And furthermore, I believe, oh no, actually that only gives us, it doesn't give us a full match. It just gives us the character. Okay, actually, the way that I was thinking we'd do it isn't going to work. Okay, I think we got to move on to today's slides, but we're going to loop back around and we're going to work on this thing a little bit later. It's a little bit tricky. Okay, let's start today's slides, and then if we have some extra time at the end of class, we'll go back to and try to finish this one. All right. Originally, I was thinking that we were going to work on asynchronous programming today, but I think I'd like to work on do the modules module instead, because well, for two reasons. One, there are some JavaScript modules which I'd like us to use in the asynchronous programming lesson, and so it would be useful to know how to install and run them. Two, so much of what you're going to do with asynchronous programming is going to involve browser, well, not just browser APIs, but basically like browser or Node.js like built-in libraries that you can work with. And that is going to be the focus of next week's module, I believe, which is being taught by Joey. So I'd like to do that one last because I think you'll have more time to practice and it'll be a bit fresher if that's the last thing that you've seen. So if everybody's okay with that, we'll get started on, we'll do modules today. So JavaScript modules, so the best way to think about is what the world would be like if we didn't have them. So you could basically imagine you have a program, you have an idea for a program, and then you write it out and everything is like super crystal clear. You know, everything is in one place and you know where everything is, but then you have an idea about how to extend it and you start to add some more code in, and then you're like, well, I kind of want to integrate this library as well, and then you add some more code, and then as the requirements continue to grow for your program, you start adding in more and more code, and suddenly you discover that the program which you've been writing for all this time, instead of having this very clear structure, everything is instead kind of mixed together and globbed together, and it resembles more of a big ball of mud than anything that's well organized or understandable. It's, you know, everything is mixed together and there are no boundaries or separations between any of the, between any of the code. And the reason why that happens is because like software grows organically. You start with one thing, but then it just grows over time. And because we're humans writing this code, it's and we're imperfect creatures. The code that we write is also imperfect, and so it's a challenge to keep it well organized, so that we can continue to understand it. So the solution to that problem is modules. So the idea behind modules is that you, instead of having like a big ball of mud, you separate things out into neat conceptual packages with well-defined interfaces. The interfaces define how data comes into it and how data goes out of it. This is called an API, an application programming interface. And when you create software that's made up of these discrete modules, which have well-documented, well-defined interfaces, then developing complex software is more like working with Legos than Play-Doh. You have little things that can connect together, little components that you can connect together to create more complex systems, and that can be reused in different contexts. Theoretically, not even just by you. You can write a module that other people can use in a completely different context. We'll talk a little bit more about that later. How to reuse software. So modules tend to have dependencies. This means that they you can have one module which is said to depend on another module. This means that it means what it sounds like. It depends on it. It needs it to run. It uses its functionality, and the nice thing about writing software with modules is that if you're using a well-designed module system, it gives you a way of automatically importing, like declaring what dependencies your module needs, and then automatically pulling them in. And some programming languages have cleaner, better ways of doing this than others. Like I've been writing some C code lately, and it has a very interesting module system. JavaScript as well is, as we'll discuss momentarily, the module system of JavaScript itself has grown organically over time. and has gone through several iterations. And we'll more about that in a minute. So another advantage of working with modules is that you can separate software out into what are called packages. And packages are basically, I mean, again, it's kind of like what it sounds like. You know, a package is basically a piece of software which has a name and it encapsulates a certain functionality, and you're able to distribute it. You can redistribute it, and the advantage of working with packages, putting your software into a particular package, is that, well, again, if you think about what we would do if we weren't working with packages, you would basically just, you know, you'd look up a module and then you'd maybe copy the code and you'd paste it into your code, and then you're copy pasting functionality everywhere, which is actually a surprisingly common programming technique. That's yeah, you'll see a lot of. I mean, it's the easiest way to duplicate functionality across different systems is to just copy paste code. But the problem that if you copy code from module A into module B, and then you find a bug in module A and you fix that code in module A, then you have to go back and take it and put it, take that fix that you made and paste it again into module B. And you have to do that across all of the software that you pasted that code into. It becomes a big maintenance nightmare. So that's why it's useful to put it into a separate package, so that you've separated it out. It means that you only have a change in one location, and that fix that you make gets propagated to all of the software that it depends on it. It's called, that philosophy is called don't repeat yourself, or DRY, or dry. So the idea is that you just avoid repeating, duplicating code. Of course, that can also backfire. There are disadvantages to that as well. Like if let's say there's a particular package that thousands of other packages depend on, and that package is somehow compromised by a malicious actor. So somebody uploads malicious code into that package, then that malicious code can get redistributed to the thousands of other packages that depend on it. And in fact, that situation, that exact situation occurred just a couple of months ago with a very popular Node.js package. The author gave write access to somebody who he shouldn't have trusted. And then that package got compromised and was redistributed across thousands of other systems with malicious software that basically looked for the private keys to your Bitcoin wallet and then would steal your Bitcoins. True story. So it cuts both ways.
So just a quick question here. A
Sure.
package is like a completely separate piece of code that you, it's like an CSS and HTML when you combine all three to communicate with each other. That's what you're talking about here when you talk about packages.
Well, that's a good question. So for now, we're just talking about JavaScript, because creating modular HTML and CSS is another, it's a different challenge. It's definitely something that that's very desirable, to basically create little reusable like HTML components or widgets. And in fact, that's there are a lot of different approaches and techniques for doing that as well. And I'd like to talk about them, but I think that might be a little bit too off topic, because that's a whole other rabbit hole. Well, maybe I'll just talk about it for just a little bit, just a minute. So so there's actually a standard for doing that for HTML, CSS, and JavaScript. It's something called, I believe it's called HTML5 components, and it's not well supported yet natively in browsers. But there's a Google library which allows you to, it basically shims the functionality into other browsers. That library is called Polymer. But this standard has received some criticism, and it seems that and so it hasn't really fully gained traction. But it seems like a more popular approach right now is there are certain like framework specific ways of creating modular components for HTML and CSS. But we haven't talked about frameworks yet, so I don't want to like dive into that. But if you hear people talk about like React and Angular and things like that, like there are a lot of HTML components for React, but of course those only work with React. So then you have a dependency on React in order to use that component. So it would be much better to have a sort of a framework agnostic way of developing and distributing HTML components, but that's not really a solved problem. But yeah, today we're mostly just talking about like JavaScript packages, which is a lot easier to reason about, because I mean, you're just dealing with like executable code. But we'll get to like a little demonstration of like what these things are and what they're useful for in just a second. So yeah, package is a little chunk of code that can be distributed and installed, and then it may have other dependencies on other packages. And then if you're using a module system, a packaging system, that packaging system should be able to figure out what those dependencies are and then install that package's dependencies. And the dependencies of that package's dependencies, and so on recursively until it's installed all of the dependencies to run that package. And the most popular module system or packaging system in JavaScript is this thing called NPM. It's pretty much the de facto standard for developing and distributing packages, JavaScript-based packages. It's definitely where most of the packages get published now. And it's basically two things. It's a online service, which is what's called a repository. It's a big repository where all the packages live. And then it's also a program which you run on your computer, which lets you download, say I want to download this package, and then it does the thing that we just talked about, where it downloads all the recursive dependencies of that package and lets you run it.
It sounds a little bit like GitHub.
Well, GitHub is kind of a part of it. So you can think of it like this. So GitHub is where is like a very popular site where people collaborate on like developing the code. It's like where they post their source code, and you can you know, review other people's code, and you can make copies of it. You know, basically like what they call forking. You can fork their code, make some copies, push it into your own fork, and then attribute it back to that original repository. And you can do all of that very easily. So it's like GitHub is for development, but it's not used as much for distributing the final versions, like what you'd call a release of a piece of software.
Like
So like once you're,
I was gonna, I said deploying the code. That's what.
well, deploying also has a slightly different meaning. So it goes kind of like this. You could imagine, like, say you're developing some piece of software. You would use GitHub to store your source code. Like you'd have a Git repository, which would live on GitHub, and you'd push and pull code to and from that repository, which is especially useful if other people are working on that code too. That's kind of the nice thing about using Git, is it's what's called it's a version control system, which means that as people make changes to it, it creates a new version of it, and then you can just pull all of the changes that they made, all these new versions, into your own local repository, so that you don't have to like basically email files back and forth, which is still, I mean, people don't do that for coding very much anymore, but they definitely do it for a whole bunch of other things. So Git is a big, GitHub is what you'd use for that. Okay, so then you've basically, let's say you've reached a point of completion on that project, and now you're ready to share it with the world in a format that they can easily consume. So then you do what's called, you make a release, or publish a release. So a release is like, it's like like usually it comes with like documentation, and it has like a version number attached to it. So let's say, you know, so like 1.0.0 might be the first release that you publish. And you typically publish it with some documentation which says, here's how you use this package, here's what the API is. And then when you publish that release, usually you're not publishing the source code with it, because you don't need that to run the program. That's kind of the big main difference between what you're doing on GitHub and what you're doing with NPM. Is with NPM, you don't need to publish all the code with it. Although the lines get a little bit blurry, because like JavaScript has not traditionally compiled language. Oh, now I have to explain. Now I have to talk about compilers. Well, it used to be that that when you were developing software, like in C and C++, let's say, it used to be that you had to compile that code. I mean, I think technically the first compiled programming language was this language called Fortran, which stands for Formula Translation, and it's still used a lot in scientific computing. I think they made that one back in the 50s, and then they made C back in the 60s. Anyway, the idea behind
Fortran in those IBM machines, like the first big, like took up a whole room, computers.
Yeah, definitely. They those things did run Fortran, and they used them to, do all kinds of different, like, scientific, and I'm sure, NASA, sure, and military applications and things like that. Yeah, it's still very, very, like, there's still a lot of like legacy scientific code out there that like requires like a specific version of Fortran in order to run, but yeah, no, it's still around, and there are open implementations of it. Anyway, the idea behind Fortran and C was that you would write your code in what's called a high-level programming language, and then you'd compile it with a program called a compiler, and it would take that code that was written in Fortran or C, and then it would convert it into what's called a low-level programming language, or I mean, actually, you wouldn't even call it that. It converts it into assembly code, which is the code that runs on your CPU, on your computer's processor. And that code is not meant to be read or written by humans. It's only meant to be read and written by machines. Although even that statement is a little bit controversial depending on who you ask. But for the most part, most people are not writing assembly code by hand nowadays. And if they are, they only do it under duress. I don't know anybody who would choose to write assembly code, only for very specific, like, embedded applications. Okay, now we're getting way off track. Anyway, so it used to be the case that you would like compile all of your code from, C or C++ or Fortran or whatever down to binary, or what's called object code, which you can't really modify easily after that. So you go from this format, which is easy for humans to read and write, to a format that's easy for computers to read and write. And the format that's easy for computers to read and write is the thing that you would publish. That's what you'd publish in your release. You'd also, if it was an open source, well, especially if it's an open source project, you also, in your source code repository, create like a tag which says, this is the source code version that we use to create this binary code version. And then you publish all of that in a release. But the thing that would go up to the repository would only be the binary code, because that's all that you need in order to run that code. You just need to publish the binary code. People didn't need the source code in order to run the program. So you'd only publish the binary code because that's all you would need to run the program. Now with JavaScript, the lines are a little bit blurry because it's not a compiled language. It's an interpreted language, which means that you don't have to compile it in order to run it, which means that often the code that you publish is the same as the code that you're editing, like the code that lives in GitHub. But even that is less and less true nowadays, because more and more JavaScript is becoming not a compiled language, but at least a transpiled one. Like, there are basically languages that are designed to live on top of JavaScript and compile down to JavaScript in order to add certain enhancements. Like, for example, a popular one is Typescript, which is a language created by Microsoft. And they call that a superset of JavaScript. And basically it adds, if you remember from our lecture on Monday, types, it allows you to declare types for your variables so that you can do to check your code before you run it for certain type-related errors. So that's one example of, a language that compiles down to JavaScript. So when you're writing code in TypeScript, it's a lot like writing code in C or Fortran. You're going to compile it, and the thing that you publish to NPM is going to be the compiled JavaScript code, but not necessarily the TypeScript source code.
So it's kind of like SAS, if I'm understanding you correctly. Right?
How do you mean?
So in SAS, it's an overlay in my vocabulary. It's probably not the right word, but to CSS so that I can use SAS.
Oh, that's SAS. Yeah, it is exactly. Yeah, that's right. Yep.
So when you're talking about modules and libraries, I'm not quite sure I understand. So suppose I have a problem that I don't know how to solve.
Yeah.
Go to
Well,
library like NPM.
Yeah.
The module building the card trick too. So like that way we didn't have to code out the whole like deck of cards. That was one way that we used a module with Gus.
Oh, that's true.
Well, let's just take a quick look. So let's go to npm.js. Let's look for like a very popular module. Okay, so this is an infamous module. It's called LeftPad. And LeftPad became kind of infamous a couple of months ago because actually, I don't think I'll be able to find it because the reason why it became infamous was because thousands of other modules were depending on it, and then the author unpublished it. So I don't know why I'm looking for it now. Okay, but let's just scroll down here and see what some of these things are. Okay, so these are things that have been recently updated. Let's see what these things are. Okay. Mushimas, a tool to bootstrap modern content management and delivery systems using GraphQL, MongoDB, Redis, and Elasticsearch. That actually sounds kind of cool. That does sound like a very modern content management system built on very modern technology. Okay, what else have we got? Oh, this is cool. Renew Formalism PT, a PTNet formalism metamodel. I think by PT, he means PetriNet, which is actually something that I'm kind of interested in. What else have we got here? Well, okay. These all, I mean, that's just a grab bag, but let's just see if there's a Hello World module that we can pull down and run. Okay, Hello World test for NPM. That sounds pretty good. All right. Although actually, I don't like this one very much because it doesn't actually have any documentation. Kind of want to find one that has like a nice API. Okay, popular libraries. Okay, here's a good one. Lodash. Yeah, okay, let's look at Lodash. All right, so we can see here, Lodash has some instructions on how to install it. Okay, this is what we run, npm install -g npm, all right, npm I save Lodash, cool. And then it has some instructions on how to run it in Node, very nice. And it says where it's supported, and it has some information about the way that it's tested using automated testing. And these are links, so presumably I can click here and go over there and see how what kind of tests they're running on it. You can see that these tests are passing. So let's try to install and run this thing. But what does it actually do actually? So it doesn't actually tell us anything about that here. Not every module does. For that, you probably, if there's a home page, you have to go to the home page. You have to look at the home page and kind of read a little bit more about it, and then learn some things about it. So it says, why Lodash? Lodash makes JavaScript easier by taking the hassle out of working with arrays, numbers, objects, strings, etc. It's good for iterating over arrays and objects and strings and manipulating and testing values and creating composite functions. So it's just like a little library of utilities. So let's try and install this thing and see how it works. Okay, so first I do npm init to create a new package. and I do npm install Lodash. And there it is. Okay. And now I have a directory in this folder called node modules. And in that directory, there is a module called Lodash. And when I write a program, I should just be able to import that library. We're going to talk more about what this require function is in just a moment, but this is just to illustrate. Let's make sure that worked. Okay, and I can see that it was able to import that library, and these are a lot of the functions that are available for me to use from that library. So yeah, so that's an example of how we can use npm to find things that are useful and then install them. Does that all make sense? Is there more? Anybody have any questions about that? So how is all of this code that's available on GitHub and npm licensed? Well, by default, when you write a module and you publish it to npm, you, as the author, own the copyright to that code, and you continue to do so unless you basically sign a legal contract that says that you assign that copyright to somebody else. And there are a variety of popular open source software libraries, or excuse me, licenses that are available for people to choose, that allows them to share that code that they've published with other people, such that they can use it sometimes with a few restrictions and sometimes with almost no restrictions. It depends on the license. So in general, there are two main branches of open source software licensing. There are copyleft licenses and non-copyleft licenses. So copyleft is kind of a made-up word that's meant to be it means like the opposite of copyright. It's meant to kind of be, so is meant to sort of subvert the concept of copyright. I think that's a fair thing to say. And basically what it, the terms of a copyleft license are designed to be a little bit viral. And what I mean by that is if you have a module A, which imports a module B, and that module B has a copyleft license, then there may be certain conditions under which the module A has to adopt the same license as the module B. So in that way, the copyleft license is designed to propagate through software systems. And the reason for that is because the original, the guy who originated this concept, his name is Richard M. Stallman, and he wanted to create software that would protect the user's freedom, the freedom to figure out how it works, and the freedom to use it, and the freedom to modify it and the freedom to share those changes with other people. I think the story goes that he was working at, he was like a grad student at MIT, and they were having some problems with their printer drivers, the drivers for their printers. And there was no source code available for those drivers. And he found that so incredibly frustrating and unjust that I guess it became his life's mission to make sure that, that, everybody had the freedom to understand how the software that they were running worked, and that it preserved their freedoms. Anyway, so that's Copyleft. And then there are a lot of other licenses that don't have those provisions, and they just say, the software is, available for you to use. Sometimes they'll say you have to preserve, like keep the copyright notice, like you have to include the copyright notice with your software, but you don't necessarily need to open source or use the same open source license of that software in your own code. Like you could basically keep your code proprietary and closed source if you want to, and you don't have to redistribute the source code of your program just because you're using that library. So I think in the Node.js world, the non-copyleft licenses are more popular. But that's something to keep in mind. It's if you're working in like a corporate environment, you'll probably want to do just a little bit of, there will often be like a license compliance process where you verify that the license that you're using is, you have to verify that you're complying with the terms of all the software licenses of the open source libraries that you're using. So it's just something to be aware of.
Okay, quick question.
Yeah.
If I go into any website under DevTools,
Yeah.
can I copy and paste the software? I mean, the code is not a secret, is what I'm saying.
That's a very good question. So that used to be true. So it used to be that you could just go to any website and then you could click like go to dev, well, there was no DevTools in the early days of the web, but there was pretty much always a view source button in web browsers so that you could view the source code of the website that you were looking at. But nowadays, so much of the web is processed using build tools. So like basically the website that you go to is more like that compiled object code that I was talking about from when from when people were programming in C than the original source code. It usually, like most software which is published to the web nowadays, goes through a build, like what's called a build process, and produces code which is designed to be like very fast for web browsers to download and run. It's optimized to reduce the time that it takes for the page to load, and it's not optimized for people to read it. That's called minification. So yeah, you could, you definitely can open DevTools on a random website and you can see what's getting downloaded, but it's not likely to be very easy to read and comprehend if, for many websites that are out there. Because it's been, because we have, the standard practice in web development nowadays is to use these build tools to try to reduce the size of the files that you're ultimately sending over the web.
What's the difference between a build tool and a module?
Well, the module, like a module is just like, I'm just trying to think about how best to like describe the difference between like a module and a package and the relationship to build tools. Like, I mean, you could basically think about like in one sense, a module is kind of just like a conceptual framework. Like it's a way of sort of dividing up your code into like, you know, it says this part does this thing, this part does this thing. And a package is like a little more concrete, right? Because a package is like, at least for NPM, a package is like a directory which has files in it, and a file called package.json, which gives that package a name, and the package is able to be uploaded to their repository and then downloaded by other people. So
Lodash was a package.
Lodash was a package, exactly. And then build tools, I think we're actually going to talk about that a bit later. I think I have some slides on it. But yeah, build tools are basically like, it's kind of like that C compiler that I was talking about earlier, or the Fortran compiler. It basically takes all of your source code, HTML, CSS, JavaScript, and it's a program that reads all of your source code, and it attempts to optimize it for distribution on the web. I mean, it does a little, it can do more than that, but that's basically, for the purposes of this class, like that's pretty much what it does. It tries to take all of your JavaScript code, stuff it into one file, you know, like your JavaScript code may be separated into multiple files. It will, first it'll do what's called bundling, where it takes all those JavaScript files and it smushes them together into one file, concatenates them in one file. And then it does what's called, it'll minify it, which is where it takes that one giant file it produced and run a code on it called a minifier, and that attempts to reduce the size of the file by doing things like removing white space from the file and potentially renaming the variables. So all the variables in the file have shorter names. And so it makes it so that it's like very fast for a computer to download it over the network because the size of the file is smaller, but it would also make it difficult for a human to read it. So that's pretty much what, you know, and then there are similar tools for HTML and CSS that do similar things. Okay. So all in all, that's the build tools are, you know, and there may be additional steps as well. Like, again, if you're working in Typescript or other languages that are not JavaScript but are designed to compile to JavaScript, you may have an extra step where you compile, you know, all the code that's written in Typescript, you compile it to JavaScript, and then you do the same process. You bundle the JavaScript into one file, and then you minify it. And yeah, so, but yeah, those build tools are, for the most part, designed to work with these packages. There's like a, the format of these packages. Well, we'll talk about that in just a second. Okay. Yeah. Anybody have any other questions? Cool. So yeah, originally JavaScript didn't have a built-in package system. And so there were a lot of ad hoc approaches, but like the most basic way you can create a module in JavaScript is by using functions to create a variable scope, and then what are called closures. So you can see an example of this here. So So this was basically in the days before we had the require function and the ability to separate JavaScript code neatly into other files that have their own module scope. This is how you would do it. This is called the module pattern in JavaScript. Basically, you declare a function, and then inside of that function, you'd have some local variables. And these local variables were designed to be private. They're not part of the public interface to the module. You didn't want people to be able to access them directly. And then the module would return its interface, its public interface. So here it's returning a name function and a number function. And both the name function and number function are able to access this array, which is called names. But the outside world wouldn't be able to access this names array. It can only be accessed through these two methods that are on the module. So you can see down here, it's calling weekday.name and weekday.number. And that's the only way that you would be able to access the internal data structures of that module. So it gives you a way to do data hiding and create public interfaces. But you know, it's a little bit funky, you know, and a little bit difficult to read. And then in terms of like sharing that code, like between, you know, code in different files, you would typically have to like put it on the global object in the browser. So for example, you know, you'd have like global variables that had like jQuery, for example. Like if you went to window.jQuery in your browser, that would be like a well-known, what you'd call like a namespace. Like basically, like it was famous enough that everybody knew not to call their module jQuery, you know, because basically what I'm saying is you could easily step on other people's modules and create incompatible modules because they were all sharing a single global scope. So those were the days before we had these, you know, this NPM and the underlying module system behind NPM. So yeah, so like the alternative to that is that you could dynamically download and run code, and you could kind of do it before by using the built-in function in JavaScript called eval. So if you had a way to go and fetch some code, then you could potentially eval it and then run that code. So like you could basically read code out of another file and then run eval on it and get the result out, and you could start to build up a module system that way. But eval is kind of evil because it puts it into it runs that code in the current scope, so it can start to change things in your current scope, which is often surprising. Like you can see here, what it's doing is you have oops, didn't mean to move that slide. You can see what it's doing here is like if I declare a variable x and assign number 1 to it, and then I run eval inside of a function which runs some code, then you can see that eval is actually running the code inside of this function scope. So it's declaring a variable called x and assigning number 2 to it. And but the outside value of x doesn't change. It's still 1. So it's a little bit surprising and unexpected behavior. So a better way to do it is to use a function constructor, which gets its own scope, and it doesn't share the scope that it's running in. So it's not going to change variables in weird and unexpected ways. Anyway, those are just some examples of like how you would go about constructing a module system. But fortunately, we don't have to do that anymore because now we have a pretty good one, which is called CommonJS. And it's the module system which is used in Node, and it grew up out of the Node ecosystem. And it's a pretty good module system. It's not natively supported in web browsers because the require function that you saw here, which you use to import other modules into your code, this require function is what's called a synchronous function, which is we'll talk about that tomorrow when we're doing asynchronous programming. But basically, the idea is that it blocks the thread of execution until that function returns. So if you're dealing with like a slow network, the function is not going to, like, no other code can execute until it's downloaded and run this module, which is fine if you're running not over a network, but it's not very good for browsers. So, but Node.js was not originally designed to run in browsers. It's designed to run locally on your machine. So, so that wasn't a problem for Node. So anyway, but more and more CommonJS is used for bundling packages that are used on the web as well. It's just that the packages that are distributed by for like modules that are like JavaScript modules that are for the web but published on NPM have to be run through one of those build tools so that it can take all of those all the JavaScript code that gets required and bundles it up into one single module that can be dropped into your web browser so that it doesn't have to like use the require function to pull modules down on the fly. So the main thing that you need to know about CommonJS, well, there are two things. One is the require function, which is used to pull in other module dependencies. We saw how to do that with the Lodash example. You know, we did npm install Lodash. It created a directory inside of Node, the Node modules directory, and inside of that directory, we have a package.json file. You can actually take a look at it here. And this has certain meta information about how to, you know, about that package. Primarily, what we need to know is its name, which is Lodash, and then and the module where we want to require that package, we reference it by its name. So we can just say require Lodash and then give an underscore, and that goes out. fetches Lodash, and brings it into our module scope. So that's how require works. And then, yeah, every basically every file when you're using CommonJS, every file that has JavaScript in it gets its own scope. So variables which are declared in that file are not shared between scopes. So for example, if I create a module called foo.js and creates a variable called bar, assigns 1 to it, I say require foo and then I do console.log bar, it's going to give me an error because it can't find bar. Bar is not defined because it was declared in the other module, which has its own scope, which back before we had CommonJS was not necessarily possible. If you imported a script in your browser and declared a variable in that script, it wouldn't be in its own scope. You could read it in another script, which is often surprising. So yeah, the other thing that you should know about CommonJS modules is basically how you create a public interface for those modules. So the way that you do that is you get an exports object like this in the scope, and then you basically attach, it's just an object like any other, and you can attach properties to that object, any properties. So so this is declaring a function called format date, but I could put this bar property on it if I wanted to, and now I can say foo.bar, run it. Oh, it didn't it wants me to download and install a package called Ordinal, which we will maybe do in just a moment. But oh, wow. Oh, I've still got this thing. Okay, and so we were able to access foo.bar, and we got number 1. So yeah, this is an example of how we consume a module. I think we've talked about that already. Yeah, if we wanted to create our own version of require, this is how we would do it, just so that you can see it's not very mysterious. We create a little cache, which basically allows us to keep track of which modules we've already loaded, so that if we try to require a module that we've already loaded, we just return that module. So we just keep it in the cache. Then in the require function, yeah, we check if the name is in the cache. If the name is not in the cache, if the name is in the cache, then we just return it. We just return its exports object. But if the name is not in the cache, we go and we read the file from the file system, and then we define an object called module, which has one property called exports, and then we initialize that object in the cache so that we map the name of the module to that module object, which we just initialized. And then we run the code that we read from the file system. We read that, we run that module's code, and we use this function constructor, which again is like a safer version of eval. And yeah, we pass in the exports object that that code uses to expose its interface, and then we get a wrapper function out of that, and then we call the wrapper function, and that initializes the module. It runs the code in the module, and we get and because we're passing in this module object, see, we're passing it in here with this exports property. The code inside of the module is able to access that and install certain properties on it. So that's how CommonJS works, and it's super popular and very common, and a very a good, robust system for developing modular JavaScript packages. So, but as I said in the beginning, there's been an evolution in the terms of module systems in JavaScript, and currently, so CommonJS was a big step forward from the previous approach of just having pretty much nothing, of just putting your objects and putting them in the global scope, and so this is a better CommonJS is definitely a step forward, but at the same time, it's like there are certain things that are not very nice about it. So one big thing is that it's not very easy to analyze just by reading the source code, because the require function takes the name of a package as a string. You can put variables in there, which basically get evaluated dynamically at runtime, like when you're running the program, and then you don't really know what module you're requiring, because you could say require variable X, and I don't know what X is. I have to run the program to find out. So that's not great. And so overall, there's a need for a better syntax, like a more native syntax for JavaScript modules. And so some of the work that's been happening in the JavaScript language has been creating a native module system for JavaScript. And this is called ES modules, which stands for ECMAScript modules. ECMAScript is like the standardized version of JavaScript. The word JavaScript is actually trademarked and owned by Oracle right now. So ECMAScript is the standardized version of JavaScript, and the one that's unencumbered by trademark. So yeah, ECMAScript modules. We're gonna take another look at that. So now, instead of having like a global, like a require function available and exposed in the module scope, instead you get some new keywords, and the new keywords are import and export. So here's an example, that same example from earlier, actually. So now you can import, you say import from. So instead of saying require ordinal, and then assigning it to a variable called ordinal, instead you're saying import ordinal from this package named ordinal. And then I can access this package, like all the exports on that package, from this object named ordinal. And likewise, you can do import, and then the names of particular named exported variables from this other package called date names. And we can see what the export looks like. Yeah, so then you can export like particular, you can see here it's exporting a function. You say export function format date, and then so you can import, you would be able to use this syntax to import the format date into another module. I'll skip the thing about default. Yeah, so here's how you consume that. You basically say import days from date names. So just keep moving along here. Yeah, another difference between ES modules and CommonJS is that all of the module imports happen before the script starts running. As opposed to with CommonJS, all the imports happen like basically right when you run the script, or wherever they appear, wherever the require function appears in the script, that's when it actually does the import. But with ECMAScript modules, it does that before the script is run. So ECMAScript modules are still pretty new. There are some browsers that natively support it, like for example, Chrome now natively supports ECMAScript modules. And currently the Node.js ecosystem is trying to figure out how best to integrate with ECMAScript modules. They've been on CommonJS for a long time, and they're trying to figure out the best way to integrate, because yeah, the two systems are not necessarily, yeah, they're not compatible with each other. They're pretty different in certain key ways. So that work is ongoing.
So
yeah.
So does that make it so that it's a little difficult to be dry, because you want everybody to be able to use your site and you want everybody to have like a full, rich experience? But if you can't do, everything with the ECMAScript or with the CommonJS, do you have to, put some substitute?
So that's a good question. The answer is that pretty much the way that you kind of have to think about who's going to be consuming your software and how. So for the browser, regardless of whether you're using CommonJS modules or ECMAScript modules, you're going to run it through a build tool. And that build tool is going to, bundle and minify and do all that stuff to get it ready to run in a web browser. So it doesn't really matter to the end user of your website whether you wrote it in CommonJS or ECMAScript modules, because you're just going to build it anyway. And but when you're creating a JavaScript library, which you're publishing, and you want other developers to be able to consume it, then it becomes a little trickier, and you have to think about who is going to be consuming it and how you want them to be able to consume it. And for the most part, I think what people do is they, because people are using, well, there are a couple of options. The first option is you basically you do what's called transpilation. You transpile your ECMAScript modules to CommonJS modules so that they can be consumed in a CommonJS context, by other CommonJS modules. That's what you do if you want people who are primarily working with CommonJS modules to be able to consume your library. Another possibility is you can compile down to what's called a universal module definition, or UMD. And basically that also allows you to, it basically kind of bundles up everything into a single file and then exposes a global variable. And this is useful if you don't just want to, the advantage of UMD is that it can be imported not just into a CommonJS context, but you could also attach a script tag to your web page and reference it in a script tag, and then it'll put that global variable in the attach it to the global window object in your browser, and then you can use that UMD module in your web browser as well without making any changes, which is, again, if you expect people to want to run your code in the browser and you just want to make it so that they can just drop it in and start experimenting with it in the browser, then you might make a UMD target, compilation target. So so if it sounds complicated, it's because it is. Yeah, because it's been a slightly messy, ad hoc, organic evolution. But yeah, that's JavaScript. So, but that's only a thing that you have to worry about if you're creating like a JavaScript library and you want other people to use it. If you're just building a website or a web application, you don't need to worry about that. You just basically need to run, just use the build tools to like build and run, to prepare your application to run on the web. And you don't need to worry about how people are going to consume it as much. So these are the slides on build tools. So we've already talked about build tools a lot, so I think we can probably skip most of this. Yeah, so we talked about bundling, we talked about minifying. And yeah, just, module design, good module design is subjective. I'll post some resources that might be helpful in terms of guiding your thinking about how you can create good modular code. But yeah, the main thing to keep in mind is that you're writing code for other people to read. You want to, think about the next guy who's going to be working on it, and you want to write code that's sort of tailored for that, for the next person who's going to be reading it and trying to understand it and use it. So that's sort of I think that's the main thing that should guide your, it's the main philosophy that should guide how you design your module system. Okay, that's it. It's 7 o'clock. Let's break for about 15 minutes, and then we'll pick up and do some exercises. Unless anybody has any questions right now before we take a break. Okay, let's pick up in 15. Thank you. Hello.
Hi.
We're back. 1 second. Let me just turn on some lights in here.
Jake, where do you live in New York?
I'm on the Upper West Side.
Oh, nice.
Yeah, it's a nice neighborhood.
Yeah.
Let's see here. Everybody back in the room? Well, we can get started. Anybody have any questions about the lecture content so far?
I mean, can we see some example of them,
Yeah.
how to implement the modules in the code?
Yeah. Let's do that. So we're going to work on an example right now. Let me share my screen. Okay. So I'm actually not sure if REPL.IT supports allowing us to create multiple files, although I think it does. Let's see if, I think it does. Yeah, it definitely does. Although I don't think it lets us do npm install. It definitely, I have to restart the session.
Could you back it up even more, like just talk through like the kind of a situation where you would even decide to use a module?
Sure. Like
the right module.
Sorry?
And how you would go about finding the right module.
Now that is an interesting question. Okay, so you use okay, so let's say you're given some task. Say you're working at a company and they say, okay, we want you to build, a system that does, calendaring or something, Let's say it needs to read from our database and then send an email when it finds a particular condition has occurred in the database, for example. Well, you probably don't want to write a database driver from scratch. So you're probably going to download a module that allows you to read some data out of the database. And then you're also probably not going to write an email client from scratch. So you're probably going to get, you're probably going to download a module that knows how to send email. So that's an example of when you would use, like when you would actually need to download some third-party modules, is basically where, the complexity, like where there's some functionality that you need, which would be really expensive to write on your own. Because the downside of using a third-party module is that somebody else wrote it and you don't know how it works, really. And it's always way more difficult and expensive to try to figure out how somebody else's code works as opposed to code that you wrote yourself. And so so there are risks involved in using third-party code in downloading somebody else's modules. There are risks in terms of quality. Maybe it's not very good. Maybe it has bugs that you're going to run into. And then there are risks in terms of security, like that one NPM package that got compromised. And then there are there are just a lot of risks in terms of using third-party code. But the benefits are enormous, because I think there's something like 500,000 packages inside of NPM right now. And the amount of time that's been spent writing that code is like no individual could duplicate that, and nor should you, because somebody already did it once and now it's available for us to use. But the process of choosing which of those packages it makes sense to use is a process of managing risk. And so selecting which module is the best one to use is, well, it's a little bit complicated and a little bit nuanced. So like, let's go back to that example that I was describing. So let's say that we wanted to, read from a PostgreSQL database and then send an email. Well, I mean, to find that, I'd probably go to npm.js, or I'd even go to Google. And then I just, search in here, I'd say PostgreSQL and see what comes up. And okay, there's a package here called PostgreSQL. And then there's some little metrics over here, which stand for I think it stands for popularity, quality, and what do those guys mean? I actually don't know what those little boxes mean.
Maintenance, it's on the left-hand side.
Oh, thanks. Yeah, popularity, quality, maintenance. So they kind of try to help you choose. Also, you can see that this thing is at 0.0.1 version and was published 5 years ago. So that's not a great indicator that this is, something that we actually would want to use for this. So anyway, and like surprisingly, I'm actually not seeing, see, I know like through experience, I know which module is the right one to use. But it's very funny that it's not coming up when I just search for it. Maybe Google would work better. Let's see, PostgreSQL Node.js module. I bet this is going to give us a better result. Okay, well, there's Node Postgres, but that's also not the one that I would use. Of course, I'm using DuckDuckGo here. Let's see if Google gives us a better result. No, it's still saying Node Postgres. Okay, but it does show the one that I would expect, which is this module called PG. Okay, so that was actually a lot more difficult than it probably should have been. Maybe Node Postgres is fine too. PG is the driver that I'm aware of. And oh, actually, these are probably the same things. I bet it is. Let's see here. We go to the GitHub page. Oh yeah, nodepostgres.com. Okay, so nodepostgres.com and the PG module are the same thing. Okay, so the lesson is use Google when you're looking for modules. It will give you a better result than the npm.js search box. But anyway, once so that's one metric, is what's at the top of the Google search. It's not a bad metric. I mean, it's but you can see there are other metrics too, which are important. So like on the npm.js page, you can see how popular this module is. So you can see here that this guy has almost 700,000 downloads a week, which is a lot. So a lot of people are using it. We can see how many, when was the last time it was published, the last version that was published, which was 15 days ago. So it seems like it's being pretty actively maintained. We can see how many open issues and pull requests there are on GitHub, which gives us some sense about the quality. And if we go to GitHub as well, and we search for, and we look at insights on GitHub, it gives you this overview, and it shows you the kind of what's been going on in the project. They call this the pulse of the project, and you can see how much activity there was. So you can see that in the past week, there's been one new open issue and 2 issues have been closed. So there's been work on 3 active issues. And that shows you basically how much activity there is in the project. And, you know, if issues are being opened, it means people are finding bugs. And if issues are being closed, it means that they're fixing bugs, presumably. So all of that should give us some confidence in the popularity and quality and robustness of this library. It means that a lot of people are using it, and it's, you know, and then you can also look at the documentation. If it has pretty good documentation, which explains how to use it, then that gives you a better sense of, you know, and you can read the documentation and understand it. And then that should give you some confidence about how easy or difficult it will be to integrate into your software. So looking at the documentation will give you a measure of confidence. And then even better, if they have a section on support, that's great, because then you know where, if you have questions or if you find bugs, how you can get support for the project. And if they have a section on professional support, that's even better, because you could potentially get your company to pay for support, which would be a nice way to support the project. Yeah, there are. So that's pretty much how I'd go about trying to evaluate whether a particular module should be used. But these things aren't foolproof either, because again, that one module that got compromised a couple of months ago was very popular with thousands of downloads every week, and that didn't prevent this particular attack from happening. Yeah, there are certain vulnerabilities in open source software, just the way that it gets developed and maintained. There's not necessarily a good financial model to support all of these projects. And so, the maintainer of that project was just like, well, I don't really have time to work on this anymore. So this person wants to work on it. So I'll just give them write access, and what's the worst that could happen? And then the worst thing happened. So just because something is popular, it doesn't necessarily mean that it's secure. And Node.js is actually doing some work around that. They'll automatically scan your packages for security vulnerabilities. This is also not foolproof, but it's better than nothing. So, but yeah, it's whenever you integrate third-party software, it's always a risk. But it's a risk that most people and companies take and live with, because the alternative is just not feasible. Nobody wants to write a PostgreSQL driver from scratch. Well, obviously, some people want to write a PostgreSQL driver from scratch because that's what this project is. We should feel very grateful for them that they want to take that on, because most of us don't have the time to do it. Most of us just want to write our application, and not write a driver. Yeah. Good question. Anybody have any other questions? We can, I posted the REPL.it session in the Slack. Let me see. I think most people are on it now. So, oops, no, my session ended. Wonder why. Okay, I'm gonna post that session one more time. Maybe I have to be active for it to work. If I go off on a tangent and start talking about something, then maybe I lose the session. Okay, looks like everybody's in there. All right, we're gonna comment this out for now. Come back to it later. Okay, so it looks like I can actually create multiple files, and I think let's just test that quickly. Okay, so we'll call this roads.js, and I'll just yeah, let's just verify that this works. Okay, let's do main.js. Okay, so we've got two modules here. Roads.js and main.js. Let's look at the problem that we're going to solve. Okay, we're going to write a common JS module based on an example from a previous chapter in the book that these slides are based on. What we're going to do is we're going to take this data structure called roads, and we're going to turn that into a graph-like data structure, where basically we're going to take this and we're going to turn it into a data structure which is composed of an array of 2-element arrays. So basically it says, you know, from here to here, from here to here, you know. So one array and then a bunch of elements, and each element has a string, and the first element means from, and then the next element means to. So we're gonna copy this guy. So let's just start by copying this guy and pasting him into roads. Okay. And now, does anybody want to start by importing this? Well, let's start by exporting this roads data structure and importing it into the main.js so that we can get roads into main.js. So we're in the roads.js module right now, and we want to take this roads array so that we can read it in the main.js. Anybody want to do that?
Can you share the link on Slack again?
Yeah. Did that work? Okay, shared. Would anybody like to get us started? How do you export a road? First of all, is anybody in the roads module? I can't see. Doesn't look like anybody's in there yet. Where is everybody? Is everybody in index.js? Everybody's in index.js. Okay, that's interesting. All right, so to get to the roads file, you're gonna go to files over on the left here, and then you're gonna click on roads.js.
Oh. Yay.
You in there?
Yes.
Okay, that's
Okay.
yeah.
Okay. Good. All right. So so let's start by exporting roads from this module. Anybody remember how to do that?
Mm. That's what I remember.
Oh, I don't see it. Did you type it in?
Is it using the export keyword?
Yeah, that's right.
I've got my multiplayer thing is like flashing, so
Oh,
it might not realize that I wrote export
okay.
in line 11.
Yeah, that's not updating for me. Maybe we're pushing REPL.it to its limits. We're definitely testing new functionality here. Might be good to try refreshing your page. Ooh, somebody's copy pasting that a lot. I'm just gonna clear out these copies if that's okay. So yeah, so it was the exports object. Would anybody like to try writing that exports? Any volunteers?
You want this in the roads?
Yeah, roads.js. Yeah, because we want to make it so that we can consume this roads data structure in another module. Anybody want to try writing exports? That it's pretty close. It needs an EX at the beginning.
So 2 EXs, because I have exports on the screen.
You do?
Yeah.
Oh.
Well, yeah, not on the Zoom, but on the my repo page, it says exports.
Wow. We might be encountering some technical difficulties in REPL.it. Sounds like people are writing things. Maybe it's on my end. But if I try to refresh the page, it might kick us all out of the session. I'm not sure. Oh, that's not good if it's not working. Oh, it looks like
Someone else just did that.
yeah. Okay. All right. Well, I guess maybe our screens will synchronize eventually. Okay. So we got exports, the exports object. Now, how do we put the a property called roads on it, given that it's just a regular object? Yeah, good. And then how do you assign something to that property? Yeah, that's how you would assign an empty object to it. How would you assign that roads array to the roads property of exports? That is, yeah, I mean, technically that's correct. That'll create an object called roads, that'll create an object with a property called roads and assign it to the roads array. But if we just wanted to export the roads property, or if you just wanted to export the roads array, yeah, you're getting closer. You could probably eliminate the squiggly brackets, and then that will assign the roads array to the roads property.
So you'll just put the brackets, the array brackets, instead of the squiggly brackets, and give it all the properties that you want to be exported.
Yeah, you don't need to use brackets in order to assign properties to an object. Yeah, it's like you use the square brackets when you're creating a new array. But then after that, and you've assigned it to a variable called roads, and you can just assign that variable to as a property on the exports object.
Okay.
So if you want to eliminate the squiggly brackets.
Oh, I did. Oh. Are they still on there? Yeah, I took them off.
Okay. All right. I don't know. It's not a perfect science. Here, I'll just update this. Oop.
I was editing it. I'm gonna stop.
Yeah. Go ahead.
Oh, I can stop.
No. I mean, you can complete what you were doing.
Okay. So I just had that. I didn't know which properties you wanted to pass to it.
Yeah. So just you just assign the roads variable to the roads property. So okay, so that would create an array with one element in it, which contains a string called roads. But you want to assign the but you don't want to create a new array. You just want to take the array which has already been created and assign that to the roads property. So so the way that you can do that is you can just write exports.roads is equal to roads. Great. You can put a semicolon there if you want to. Okay, good. All right, let's switch over to the main.js module. Okay. And here we're gonna, so who would like to try to import the roads array into main.js? Anybody remember how to do that? Anybody remember what the what function we call to do the import? Yeah, that's correct. You got to use require, and then how do you specify the module name for the module that you want to require? So require is a function, so you're calling a function.
Wasn't it underscore and then the name of the?
Oh no, you don't need to use underscore. Underscore was the yeah, okay, that's looking good.
Okay.
Yep. And then you want to give it, and then how do you specify the name of the module that you're, yeah, okay. Oh, perfect. Yeah, that's looking great. Okay, and then what? Yeah, very nice. Cool. So so that's going to take the exports object of roads, and it's going to evaluate roads, and then you got to assign that exports object to a local variable. So does anybody want to assign that to a local variable called roads? Cool. Okay. And then does anybody want to console.log that so that we can see what's in it? See what's in the properties are of that variable. Cool. Roads needs to be capitalized there. Yeah, good. Okay, let's try to run that, see what comes out. Oh, maybe it doesn't know which file to run now. Rename. We'll just do it like this. I just do require main. Then I think that should run it. Yeah, good. Okay. Okay, great. So we got the array out. Can you modify console.log so that it only prints out the array? It doesn't print out the whole exports object. So if we just want to print out the array roads, and so that we're accessing that property, so we just do, how would we do that? Yeah, that's looking good.
The name of the array,
Yep.
I don't,
The name of the array is roads. Good. Let's try to run that. That's odd. Identifier roads has already been declared. Is that? Runner roads.js. I think that's doing that because of a weird REPL thing. Oh, no, there's some extra copy pasted code here, which it doesn't like. That's why. Okay. There, that's working. Okay, very nice. Okay, good. So, so now we've exported some data from one, and then we've imported it into another module. So let's try to do something useful with this data. Let's do a little let's write a little algorithm now that's going to take the strings in this array and split them up into an array of 2 elements. Yeah, nice. Yeah. So, so for example, we're going to go from the string Alice's house, Bob's house, to the string to an array of 2 strings, which says Alice's house and Bob's house, like that. Does anybody want to take a crack at writing this function? You can call it split strings.
so we'll be, you want us to split the roads arrays into 2 substrings? I don't understand the prompt.
Yeah, so basically take that roads array, and right now that roads array, it's an array of strings. And each one of those strings, it has like, it's like the name of 2 places. And each place is separated by a dash, like Alice's house dash Bob's house. And so we want to write a little algorithm, a little function that will step through the array and turn each element, convert it from a string to an array of 2 strings. So instead of being 1 string, which says Alice's house dash Bob's house, it'll be an array of 2 strings, which says Alice's house, comma, Bob's house.
And you want to assign the function to a variable, right?
Yeah. Basically, declare a new function that does this, and then call that function and pass it the local roads, pass it the roads array. Yeah, so you want to give it a, yep. So I like how you're thinking. We can try to run this function, or we can try to run this code and see what happens. So let's see what's happening so far. Okay. Well, so there's a syntax error. The syntax error says that it doesn't like that dot in the function parameters, the parameters of split array. So so you're probably going to want to rename that to the name of a different variable, like maybe local roads. Or maybe you don't even need to use a parameter. Maybe you're just going to reference, the local roads variable, which is declared in the outside of the scope of the function. So maybe you can even just remove the parameter, and that's valid code. Yeah. Let's try to run that again and see what happens. Okay, that's working fine. But you're gonna need to call this function as well. So you probably put the function call down below the function. Sure. All right, let's try running that. Okay, so it says local roads.split is not a function. So why do you think local roads.split is not a function? You can see up above we're calling console.log on local roads.roads. So what is roads? Like, what is local roads.roads?
It's been reassigned to roads has been reassigned to local roads, so you don't need to call roads anymore.
No, you definitely do. Yeah.
Oh.
But I'm saying, like, what is the type of local roads.roads? Like, what is it? Yeah, it's an array. So so you probably don't need to split the array. Like, the split method is called on a string. So that's good thinking, because you're probably going to use split later on to split the string. But first you have to get to the string. Given that you are going to be doing the same thing to every element of the array, what is typically used when you're trying to do the same thing to every element of an array?
Index position. I'm just kidding. No, never mind.
Yeah, that's looking good. Yeah. Yeah. So keep it going. Definitely write that for loop. Mm-hmm. Mm-hmm. Yep. 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 Okay. So then the question is, what do you Like when you're indexing into it at that point, what are you getting out of the array, and what do you want to do with the value that you're getting? So first of all, what are you getting? Like, what's the type of the value that you're getting when you index into localroads.roads? You can console.log it if you like, and then you can see what you're getting. Oh, I wouldn't. Yeah, I mean, you could do type of, although that needs to be a capital O and not a 0. Yeah, and yeah, you could do console.log on that. Yeah, yeah. Sure, you can run that.
Can you just split the local roads.roads that index position and just use put dot split and then put the brackets in it to split that in that specific, I can't speak, to split the string?
Yeah, that would work. Yep. Do you want to try doing that?
Is that how she had it?
It's a dash and not a comma.
Okay.
And you probably want to remove the type of. Yeah. Yeah. Okay. So yeah. Yeah, good. So if you want to try to run that.
Okay.
Oh, you're going to want to put a dash back in there.
Oh. Is that right?
This is just an extra one of these. Okay. Yeah, that's right. Okay. Now if you want to run that. Okay, good. So we have, we've split the array, each element of the array. So now we just need to do one more thing, which is you want to, like each one of those strings that you've split, you want to accumulate them into a new array and then return that array from this function. So first you want to declare a new array. You can call it like toReturn or something like that. You want to declare it probably at the top of split array. So create a new array at the top of split array.
Okay, so just this is completely doesn't. I mean, it might have to do with this, but when is it best to use the var or let?
Yeah. So you should pretty much always use let. Yeah. Yeah. The differences are basically var has function scope and let has block scope. And let pretty much always is what you want to do. Yeah. So I would just use let all the time. So if you want to create a new array at the top of split array, yep, that looks good. But maybe put that inside of the split array function, so that it's scoped, so that it's inside. Yeah, so that it can't be accessed outside of that function. Good. And then you're going to want to add each array that you're creating using local roads index I.split. You want to add each of those arrays you're creating to the new array that you've created. So you can get rid of the console.log around local roads.split. Yep, that looks good. And then you want to take the value that's being created there when you call split, and you want to add that to the new array. So do you know what method you call on the new array in order to do that? Yep, exactly. And you got to call that, yep, that's looking good. Cool. And then you just want to return new array. Awesome. And maybe if you want to wrap where you're calling split array in console.log so we can see what we're getting. Oh no, sorry, I didn't mean right there. Just down under on line 15. If you just want to wrap that in a console.log. You can verify that it works. So if you want to click on run. Yeah, I don't know if I get to, I don't know if I can see the run screen when other people click on run. I think maybe I have to do it. Okay, and this is the new array of arrays that we created. Very nice. So let's do one last thing as a part of this exercise. And I'm going to create a new file here. I'll call it util. And let's take this function out of main.js, this split array function, and move it into util, and export it from util, and then import it into main.js, and then call it from main.js. Anybody want to? Yep, that's good. Oh, missed the last bracket. That's okay. We'll come back for it. Put in util. Okay, good. Needs a closing bracket. Very nice. And then you want to export it using the exports object. With an S. Yeah. And then you do exports dot, right? And whatever you want the Sure. Oh, you gotta call it the name of the function. Yeah, nice. Okay, cool. And then we can switch back over to main.js. And now let's import that guy using require. So the same thing that we're doing with local roads at the top. We want to do with util. Anybody want to call require?
Hey, can somebody else take these?
Yeah, who hasn't gone yet?
I would love to go, except my internet connection is apparently not stable enough to support real-time REPL.
I hear you.
I've been fighting with it for, I don't know, too long.
Okay, that's good to know. This is all new.
Yeah, my typing isn't showing up either. Whenever.
Okay, that's good. That's good feedback. We might try something other than REPL.it.
Well, it's too bad because I really like it. It's really fun.
There are some other products that we could try. Yeah, some other like cloud coding environments. But I agree, it's like been pretty fun and easy to set up. But yeah, I mean, everybody can't participate. It doesn't work. Doesn't work.
Not fun.
Yeah, it's not good. No, so I'm sure they'd love to get this feedback as well. Anyway, anybody want to take us home? Well, anybody who's got a working REPL, I guess. Yeah, nice. Yep. Awesome. Good. And then, yeah, just call that function, which is going to be called the splits. Yeah, so right on line 9 there, where it's doing console.log. So how are you going to reference that function? Like yeah. Like it's going to, like in order to call the split array function, it'll be local splits dot what? Yeah, nice. And then how do you call a function? Yeah, very good. Okay. Now I'm just realizing there's going to be one other thing that we have to do in order to make this work. Does anybody see what that is? So before, local roads.roads was outside of, it was in our module scope, but now it no longer is in our module scope, and we have to pass it in as a parameter. Can anybody modify the split array function so that local roads, so that the roads array is passed in as a parameter in util.js? So that's a good attempt, but that's actually going to cause a syntax error. So we need to do it a different way. Yeah, that's good. And then you're going to go through and modify the function, the rest of the references to local roads.roads. You're going to want to just delete the local roads part of it, local roads dot part of it, so that it's just roads. Yep. That's good teamwork. I like seeing multiple people edit one file at the same time. It's kind of satisfying. Okay, cool. That looks good. So then let's go back into the main module, and we just gotta bring it home. Let's pass the local roads.roads into the splits, into where we're calling the splits, and then let's assign the result to a variable, and then let's console.log the variable. Ooh, that I don't think we need angle brackets there, or squiggly brackets there. Yeah. So let's assign the output of that function call, the splits, to a variable.
Is that correct?
Just waiting for my screen to update. Yeah, you need a variable name. Good. And then if you want to do console.log on that guy so we can see what the output is. Good. Okay. And then there's just one last thing that's needed here, which is that we still need to reference local roads.roads. Or I'll show you now an alternative syntax that you can use. You can say roads like this. And that's what's called a destructuring assignment. And it basically says, like, that's basically the same thing as doing that. It's just a nicer syntax for it. So it lets you take properties from an object and assign them to local variables. And I think that's it. I think that should work. Yeah, and that's it. We're done. Okay, very nice. Good job, everybody. So I think we've got 12 more minutes, and maybe we can return to that regular expression thing from the beginning of class, if anybody wants to stick around. Does anybody have any questions about modules right now? I think a really great thing to do would be, like, as an assignment tonight, would be to try to create an NPM package locally using npm init I think everybody has Node installed. Is that correct? Cool. So, so if you would like to,
Actually, no, we don't.
oh,
we
you don't
have it
have.
installed on Visual Studio. Never mind.
Oh, okay. All right. That's fine. As long as you can access the console, because that's the way that you'll typically use NPM is through the console.
Right.
So if you want to try to initialize a new package locally, and then npm install Lodash, that would be a good first step to do at home.
Okay. So how many modules are there in JavaScript?
Well, in npm, there are about 500,000.
Okay, good to know.
Yeah, yeah. Which is a large ecosystem. And I think it's fair to say that most of them, not all of them, are very high quality. There's definitely a mix in terms of quality, but yeah, it's definitely the breadth and depth of the ecosystem is impressive, because JavaScript is such a popular language. You know, like there are so many JavaScript developers out there doing so many different things with the language that it's, you know, there's this really rich ecosystem of packages out there for JavaScript. So yeah, just about anything that you can think of, somebody has maybe written a module for it. So.
And they all have different syntax?
Well, I mean, they have different APIs, right?
Yeah.
But the syntax of the language is the same. It kind of has to be the same, because if the syntax changes, then the program that runs your code won't know how to interpret it. But yeah, they all have different interfaces, basically, except for the ones that are explicitly trying to copy a different module's interface. Like, for example, that module that we were using called Lodash, it's explicitly trying to copy the interface of a different module called Underscore, which was written by a guy named Jeremy Ashkenas, I think his name is. And Underscore was what continues to be a super popular library. And Lodash was trying to do the exact same thing, but do it in a way that was like smaller and faster and more optimized. So that's actually an example of a package that, you know, both of those libraries would have the exact same API, the same interface, and that's by design. But that won't normally happen unless there's some standard that they're attempting to adhere to, or some de facto standard. And and I could talk about standards, but maybe we'll save that for a different lesson. So anybody have any other questions? Should we go back to working on this regular expression? Got 7 minutes to try to figure it out.
No pressure.
Yeah, no pressure.
Been bothering me.
Yeah, it's bothering me too. So I feel like I have to fix it. Okay, all right. So yeah, so how do we swap out? I mean, let's just start with the other end of it, right? Let's just replace everything with everything, and we're not going to worry about contractions. And we'll just see what that looks like. Okay. Okay, so that does what we think it would do. And then we also want to avoid, and so basically we want to say, if, yeah, if there's a, yeah, then we're back to this, because that looks like a contraction. We want to say not that. So it's kind of like, okay, let's try it like this. We're just going to break it down into different cases, right? Okay, so we're going to say that this is fine. Good. Okay, we replaced the first quote. And then we're going to say, or, big or here. Yeah, so if we've got a quote at the start, single quote at the start, then we're going to replace it. Okay. And then subsequently, anything can happen. And if we, and then we're going to replace everything that looks like this. Let's try that. Oops. Almost. Yeah, because we actually want to preserve. Okay, that's a little bit too much. Yeah, that was too many things. Okay, so we got to use or. All right. So let's try it like this. Or that. Okay, we're getting there.
Mm-hmm.
Now we are also missing
A comma.
yeah, so we have to resolve that problem. So let's use those things. And we'll do 1 and 2. Okay, that's looking pretty good. Now this guy is not getting swapped out. And that's because
seeing it as a one with a space in front of it.
I think, why was that? It was non-character. So this guy is matching everything that's.
We need to put an S somewhere for that one. Like slash, backslash.
That's a single quote.
Let's do the last quote and then we'll deal with this one guy here. Okay, so I think this guy should take care of the last quote. Yes, okay. So now we're just down to this one last single quote. We have to figure it out. Okay, so the dollar sign, by the way, means end of line. So caret means beginning of line, dollar means end of line. So this is basically saying if there's a single quote at the beginning of the line, or if there's a single quote at the end of the line, or if there's a single quote which is surrounded by two
alphanumeric characters.
Things that are not alphanumeric characters.
Not capital.
Yeah,
not.
Yeah, exactly. Not alphanumeric. So this is the part that I'm getting a little confused on. Basically, it's only going to match things that are not surrounded by alphanumeric characters. But this thing has one, why?
Yeah.
Because it's got one alphanumeric character, but then the other one is a white space. And so it seems like it should match that. and it's confusing me that it's not. So much so that I wonder if I'm using this correctly. Two non-alphanumeric characters. I'm going to try to replace this with something else. Okay, A to Z, capital A to capital Z. So basically, yeah, that's should be the same. Let's verify that. Not A to Z, capital A to capital Z. Verify. Okay, and in fact, we just lost one, so that was even worse.
And this is how that email validation thing got to be so crazy looking.
Yeah, pretty much. I mean, also there are so many variations on what email validation, like on how you can write email addresses. There are just like so many special cases.
Right.
Because that actually
words and
yeah, that actually is a standard like email address is it's in a RFC request for comments. But yeah, that's why it's super complex, is because there are so many edge cases. Yeah, so this is non-alpha and this is non-alpha. I'm going to say that if we make this one optional, I bet it's going to work. Yes, we did it. It did it. We did it. It worked. It worked for this particular sentence.
No,
but
oh, for this particular sentence, yeah, I guess.
Yeah, but I wouldn't put this into production. But but we managed to get it working. Oh, and on time too. It's 8:31.
Yeah.
Okay, very nice. Nice work. Nice lesson. Thank you. If anybody has any other questions, yeah, write it down and we'll have some time to talk about it before class tomorrow.
Okay, great. Thanks, Jake.
Thank you very much. Have a nice night.
You
Night.
You.
Bye.
Bye.